Solutions to the study guide. I'm going to remind you, you should do this first. You should try your best, and then if you're stuck, or if you want to see if the answer is correct, then play the video to see. Copying this video will not make the test any better. So do your best. I totally believe in you, and you're going to do great on the exam. So let's do this together. So number one, you've already done it. Derivative integration onto each other. This is a fundamental theoretical calculus question. This is a substitution question. If you plug in -2 and take the derivative, the answer is 0. Subtract, then plug in the lower bound, and we just substitute in. So where there's a t, you plug that in. And then the hook is the derivative of the limit. That's 3x squared. Write down the integrals that represent the area of this. That's top, subtract bottom. That's an integration question. We go from 0 to 1. That's 1. And then which one is on top? So that's the cube function that's on top. So that's -x cubed plus 2x. Subtract the bottom, which is the quadratic, x squared minus x dx. That's it. Top, subtract bottom. Which of the following is a midpoint Riemann sum? Approximating. That's using rectangles. So let's first of all find the width. So it goes from 1 to 5. So that's 5, take away 1. And how many rectangles? 2 rectangles. So divide by 2. So the width of each one is 2. And then we have to find the heights. It might be helpful to even draw a number line from 1 to 5. So here's 1 to 5. And the width of each one is 2. So it goes 1 to 3. And then 3 to 5. There are my 2 rectangles. A midpoint means I use the middle x value. So I'm going to first use 2 for the height. So I plug 2 in. I don't have to simplify it. Plus the next mid value would be 4. Again, I don't have to simplify unless I have to. And there it is. That's a midpoint Riemann sum to approximate the area underneath the curve. All right. The region on the right is this equation. Which integral represents the volume of a solid whose base is a semicircle? So this is an integration question. It goes from 1 to 2. And the formula for a semicircle is 1/2 pi r squared. And we need to know what the base is. So the base is top subtract bottom. So that's 4x subtract x cubed. Subtract the bottom, which is 0. We don't need it. And to recognize that for a semicircle, that base is the diameter. So if I want the radius, I have to divide that base by 2. So that's 4x subtract x cubed divided by 2. Now it's the radius, and there's the setup. All right, just an integration question. So this is anti-chain or hook. Where does the hook come from? The derivative of 3t minus 1 is 3. What was it before, and what did it become? So it was a 1, and it became a 3. Now circle the hook and let it go. So it starts with 1/3, and then copy 3t minus 1, and then add 1 to the exponent and divide, and that's it. This is an integration to do with graphing. So I need to know where the graph is. So the absolute value of x minus 1. You can take x minus 1 equal to 0. The vertex is at 1 right there. Plug in -2, and you get 3 for an answer, because the absolute value is always positive. Connect. Plug in +2, and you get the answer 1. Connect. And then there are 2 triangles to find the area of, to integrate. So the answer here, the first triangle is 1/2. The base, 1, 2, how long is the base here? 1, 2, 3, right? And then the height, we said was 3 plus half the base. This one's 1, and the height is 1. You don't actually have to simplify it. If you did, it would be 9 plus 1, which is 10 over 2, which equals 5. That's unnecessary. That's perfect, and you have the answer. Number 7. Again, the hope is you tried it first. Which of the following is the right Riemann sum of this? So the width would be 4 subtract 1 divided by 3. And then each height. So the first one goes 1 to 2, and we're using right. So 1 to 2, we're using the 2. You plug it into here. That's 2 squared. Subtract 4 times 2 plus 5. That's good. Then the next one goes from, so the first one, sorry, let's try it again. So 1 to 2, good. The next one goes 2 to 3, so I'm going to plug in 3. Again, I don't even, unless I have to, I'm not simplifying. And then the next one would be 4 for the right hand. And that's it. There's your right Riemann sum for this. All right, which of the following trapezoidal, using the same one, right, from up here, the trapezoidal rule, using 3. So same width, same work, but the trapezoidal rule starts with 1/2 times the width. And then I got to use all the heights for each trapezoid. So the first height is 1. The next height I'm going to double using 2. Next height I'm going to double, use 3. And then the last one I don't double, using 4. Done. Number 9, use piecewise here. So we have a couple pieces here. Integration means area, so find that from -3 to 5. So from -3 all the way to 5. So first of all, this is a semicircle. Find the area. It's important to know that area above is positive. So the formula for a semicircle is pi r squared divided by 2. The radius here is 3 plus. This is a triangle. It's also important to know this is negative because it's below the axes. So it's half the base times. Now if you write the height as -4, then it's already negative and it's all set, and that's a great answer. You could also write the answer as 9 pi over 2. Take away 4, same answer. All right, evaluate this. Write it friendly. 5 take away 2x to the -3. The hook is -2. So it was 1 and became -2. So the answer is -1/2. Copy. And then add 1 to the exponent and divide, plus c. Next page. Again, the hope is that you did these first and are learning. This is a u substitution. So u is equal to x minus 1. X, you add 1, and then the derivative of x is equal to the derivative of u. Come back here. In fact, we're going to change the bounds. So I'm going to plug 2 into here. So 2 take away 1. There's the new bound. I'm going to plug 1 into here. So 1 take away 1. That's the new bound. And then we have 4. X is u plus 1. And then x minus 1 is u. I'm going to write that to the 1/2. There's step 1. We're going to distribute. It's okay to go one at a time. So I'm going to go 4u plus 4. Then I'm going to distribute again. I haven't done any calculus yet. I'm going to multiply. So 4, think of this as an exponent 1. When you multiply it, 4, add the exponent. So it's going to be 3 over 2. And then 4 times u to the 1/2. We're finally ready to now integrate. So what does that mean? I add 1 to the exponent. That's 5 over 2. And then I do the reciprocal. Again, I add 1 to the exponent. And then I do the reciprocal. And it goes from 0 to 1. I don't need to use x again because I changed the bounds in terms of u. And then the last step, so this would be 8 over 5, plug in 1, plus 8 over 3, plug in 1, subtract, parentheses, 8 over 5, plug in 0. That's going to be 0, right? Plus 8 over 3, 0. That's also going to be 0. But there it is. The top, subtract the bottom. All right, sketch this. Y equals 3. That's a horizontal line at 3. And then this is a parabola. The vertex is at +1 and 0. We go up 3 and to the right 1, if you like. There's my parabola. Show an integral setup. If you want to, because you can't see it, you could make them equal to each other to find the bounds. To do that, I would divide by 3. Then when you square root, it's positive or -1. So it could be 1. The other one could be -1. And then when you add 1, we get the answers, which are 2 and 0. Those are my bounds, and you can see it's 0 and 2 off the graph too. So it's going to be 0 to 2. Area is top, subtract bottom. So 3 is on top, subtract the parabola on the bottom, and there it is. So there's the setup to find the area. Average value. So average value is an integration question. We're going to go from 0 to 3, and we're going to integrate this. And then we divide by the difference of the bounds. Oops. So then we divide by 3, take away 0, or 3. Now, there's a 1/3 here. So 3 take away 0 is 3. 1/3, it might be helpful just to write that in front and then integrate this, which is add 1 to the exponent and divide, add 1 to the exponent and divide, and then negative 1 is just x. I'm going to plug in 3. Subtract. When I plug in 0, the answer is 0. Alright, so we got here 27 divided by 3, that's 9. 9 divided by 2, take away 3. So 9 take away 6, 3 is 6. Common denominators. So it's 1/3. That's going to be 12 plus 9. That's 21 over 2. That's 21 over 6. Then it says find the values in terms of from 0 to 3. Made a mistake because that's not from 0 to 3. So where did I make a mistake? So 3, 3, and 3. 27 divided by 3 is 9. 9 divided by 2 minus 3. Yeah, let this one go. So, we integrated it. This would be like a calculator question. I'm trying to think where it feels like I might have made a mistake. So we have x squared plus x minus 1 over the difference of the bounds. That's 1/3. Then I integrate it. I plug in 3. And then again, that's 27 divided by 3. That's 9 divided by 2. Take away 3. 9 take away 3 is 6. Common denominators, 12 plus 9. Still get 21 over 6. And then you'd use a calculator and use the solve feature. So on the test here, you would simplify it, and the number would simplify to something far easier than that. And then you would make it equal to what the equation is, and then you would solve it. And again, if you needed it, you won't need a calculator on it, but this is a calculator question for sure in terms of doing it. So I'm going to let it go. 14. At every point y equals this, f of x, find an equation for the function, which means if you're given the derivative, integrate this. So to integrate this, we're going to write it calculus friendly. I need to know where the hook comes from. So it comes from inside the parentheses. So the derivative of x squared plus 2 is 2x. That's the hook. That's the proper hook. And it was a 1 and it became a half. So now that 2x can go away and our answer starts with 1/2. And then we're going to add 1 to the exponent. And then instead of dividing, we're going to go times the reciprocal plus c. And then I'm going to use this point to find what c equals. So y is 1. This is the 2's cross out. This is 1/3. And then plug in 0 for x. All right, this does not simplify to something nice because that's the square root of 2 times 3. That's irrational. So I'm going to multiply both sides by 3 and then divide by 2 to the 3 halves. That's what C equals. Oh no, let's try that again. I'm just going to subtract. So it's 1 subtract. That's what C equals. Just subtract to get it by itself. And then put it all together. So it's Y equals, from here, 1/3 x squared plus 2 over 3 halves. And then C is 1 minus some ugly number. Just copy it down. And you did it. Think of the process. We're going to integrate the hook, and then we integrated it, and then you have to plug in the point, 0, 1, and solve for C, and then finish it off. All right, number 15. Look at this. What's the area of this region? So it's an integration question from -1/2 to 1, and area is top subtract bottom. So that is x squared plus 1 cubed subtract 0, or just that, and it's done. The volume, when you revolve around y equals 8, so volume is pi circles. Is there a space here? Yes, so we have 2 of them, subtracting. And then the big radius goes 8 to 0, so 8 take away 0, or just 8. And then the small radius is 8 subtract the curve. All right, find the volume if the cross sections are semicircles. So we're still integrating from -0.5 to 1. The formula is 1/2 pi r squared. And then inside here, if these are going to be semicircles, it's just top subtract bottom. So we don't have a line of revolution, just that area. So when we went top subtract bottom right here, we got x squared plus 1. We just need to divide it by 2 because top subtract bottom is the diameter. So divide by 2, and now that's the radius, and there's the setup for a semicircle. All right, last one. So the graph at the right shows a rate graph. And it says given from the integration from 2 to 7 is 17. So from here to here, this area from 2 to there, that area is 17. So I don't need to find it. It was given to me. It says what was the average velocity of the tortoise between 2 and 7? So that's like average value. So that's an divide. And then on top of the divide sign, we're going to integrate from 2 to 7. And we integrate the velocity. And then we divide by the difference of the bounds. So we're integrating from 2 to 7 and divide by the difference of the bounds. So the integration from 2 to 7 is already done for me. It's 17. And 7 take away 2 is 5. And then it says include units. So the velocity is in meters per hour. So the average velocity was 17 over 5 meters per hour, a little more than 3. Next it says find the integration from 1 to 7. Well, the integration from 2 to 7 has already been done. 1 to 7, there's one rectangle here I haven't found the area of. So I need to find the area of that rectangle and add it to what we already know. So this rectangle is 1 by 3. That's 3. So we're really just going 3 plus 17. And that answer is 20. And then write an exact sentence on what the answer means. So if I'm integrating from 1 to 7, it means from 1 p.m. to 7 p.m. What happened? The tortoise walked a total distance of 20 meters. It's important that when you integrate, it's no longer going to be velocity. So when you integrate it, this answer is simply the total distance. It accumulates how many meters the tortoise has gone. And so the tortoise has gone 20 meters. All right, you finished the study guide. Good luck on the exam. Study. I believe in you. You're going to do great. Mr. G Math.